Deriving and applying conditional probability formula. This presentation focuses on deriving and applying the conditional probability formula. Let's start by understanding what is conditional probability. It is a measure of the probability of an event occurring given that another event has already occurred. We note that two events occurring in sequence, that is one following the other, are mutually exclusive, that is not independent. And understand this to say not independent. If they are independent, that means the intersection is not empty. If they are not independent, that means the intersection is empty. Hence, they are mutually exclusive. We note that conditional probability can be calculated from information presented in contingent tables, Venn diagrams, or tree diagrams. Let us derive the conditional probability formula. Here is a situation. In this Venn diagram, S is a set of all people in South Africa, A set of Katisa High School students, B, a set of all people who live in Gumbani village. Now, suppose that we pick a random person in South Africa. Remember, everyone has an equal chance of being picked. Therefore, what is the probability that the person is a Katisa High School student, given that the person is a Gumbani village resident? Ask it differently. We are saying what is the fraction of Gumbani village residents that are also Katisa High School students? This question is a conditional probability question. But we need to understand that both events A and B, that is this part, have a low probability, right? Because that's what we want to calculate to say that the person we are told is a Gumbani resident, right? But we want to check the probability that he is at Katisa, so that person falls in this region. This is why we are saying it has low probability because South Africa is a very big country. When you pick a person in South Africa, the possibility that that person will be in Gumbani and at Katisa High School is very limited. Therefore, to answer to our question, which requests us to find the probability that the person who is said to be in Gumbani is a Katisa High School student, we can write that in a special notation. That is the probability of A given that B is okay. That is the probability that the person is a Katisa High School student given that he or she is a Gumbani village resident. So the fact that a Katisa High School student represented by A, right, given that he or she is a Gumbani village resident represented by B. So that's the special notation to represent the situation we are dealing with. So how do we compute this probability, right? Since we are given that the person lives in Gumbani village, all outcomes outside of event B are irrelevant. They are now useless. We are not going to consider them because we know the person is in Gumbani. That is to say, in the Venn diagram, the probability space is reduced to just B. The probability space or the sample space have been reduced to B since B has already occurred. What you need to understand is conditional probability restricts or reduces the sample space. So as you have seen in this situation. Now, the conditional probability formula can be derived. Step number 1, we start intuitively with probability of A given that B has happened being a fraction of Gumbani village residents that are also Katisa High School residents. That is the intersection. That is where we are starting from. This is why we are saying the probability of this conditional is the same as number of elements on the intersection over the number of elements in set B, right? So with that as our second step, we need to divide the numerator and denominator of the right hand by the number of elements in set S. That is, we divide this numerator and the denominator, which is what I have here, divided by the number of elements in set S, number of elements in set S. So the fact that what I've done in the numerator, I've done it also in the denominator. It means it's still the same to say this is equal to that, because this can be reduced to that. With that, then we substitute the probability of A intersection B, which is represented by this fraction. Then this fraction will represent the probability of B. So this is exactly what happened here. So as a result, this is the conditional probability formula. Let us summarize the conditional probability formula. As it is written, it simply means the probability that the person is in set A intersection B, that is this part, right? Divided by the probability that the person is in set B, that is the new sample space or probability space, right? That's the meaning of this formula. And remember, these are probabilities. They are not a number of elements, but the probability. We know that in that formula, it is an equation. We can play around with the variables there. So if I make probability of A intersection B subject to the formula, I simply multiply both sides by probability of B, and the result is this. So you can play around with the formula the way it is necessary. Example number 1. A math teacher gave a class 2 tests. 25% of the class passed both tests, and 42% of the class passed the first test. What percent of those who passed the first test also passed the second test? Already, this is a conditional probability, because we want to know those who passed the first test also passed the second test. Meaning we first define our variable T1, first test, T2, second test. Then we put that in a mini Venn diagram. Then we try to position given information. 25% of class passed both tests. So that means they are on the intersection. Then 42% of the class passed the first test. So the red represents the first test, but we already have 25%. So we want to find the probability of those who passed test 1 only. Probability of passing test 1 only is equals to the 42 that passed the first test minus those who are also people who passed the second test, so that we get the 17% is those who passed test 1 only. So I filled that information. Then we go on to try to answer our question. The fact that we want those who passed the first test also passed the second test. So it will be second test given that they passed the first test. So this is the symbol, and this, its interpretation simply means probability of test 1 and test 2 over probability of test 1, right? So that's our conditional probability formula. Or what we need to do is identify the information and plug in. So as such, probability of test 1 and test 2 is the intersection, which is 25%, which is 0.25, 25 over 100, over the probability of passing test 1, which is what we are given already is 42, or you add the probabilities in the red circle which is also 42, which is 0.42, approximately 0.60 to 2 decimal places, which is 60%. So reduced sample space for the question is now T1, right? Because of this, given that it has happened, so that is now the sample space, right? Whose probability is 42%, right? So we need to understand that here, when we talk of conditional probabilities, we are already talking of probabilities, not number of elements in a set, but not to say always the questions that are given will be given in terms of probabilities. They can be given in terms of number of elements in some set. But what you simply have to know is it will be probability of the intersection of the two sets over probability to the one that would have been the conditional one. That is important. You will see maybe in the next example, although it doesn't show. However, example 2, at Katisa High School, the probability that a student takes mathematics accounting A is 0.087. The probability that a student takes mathematics is 0.68. What is the probability that a student takes accounting given that the student is taking mathematics? So we know the student is taking mathematics already, but we want to calculate the probability that he is also taking accounting. So it's conditional probability. The first thing, define the variables, although already they were indicated, but that is trying to emphasize. Then in a mini Venn diagram, we are simply saying, yes, maths accounting. Let's look at the information. We are told that that student takes maths and accounting is that. So that is the intersection. So we place that on the intersection. The probability that a student takes mathematics is 68. If you look at the mathematics, the red circle, it should be 0.68, but already we have 0.087. That means to find the probability of those who take mathematics only, we need then to say 0.68, which is this one, minus 0.087, which gives us 0.593. Then that is what occupies there. So that if we add these two, you still get 0.68, right? It's a way of trying to make sure that you understand it, terms representing the information that you are given. It will help you understand the problem. So right now, what we want is to answer the problem. So we need to define the student is taking maths already, but we want to find whether it's taking, what is the probability of him taking or her taking accounting. So probability of taking accounting given that the student is doing mathematics. So it will be probability of A and M, that is accounting and mathematics, over probability of mathematics, the reduced sample space. Then from there, we plug those things in. The probability of A and M is what we have here. Then the probability of M is what we have here. Then we plug it in approximately 0.13, which is 13% to 2 decimal places. So you see, presenting the information in the diagram, like I said, it's for you to understand what is going on, so that even if maybe at some point you don't realize that 0.68 is the probability of taking mathematics, but once you have put in the diagram, you could add all what is inside, then obviously you see that it will be 0.68. So what was important in this presentation is the idea of conditional probability. The formula itself is very important, and the formula of conditional probability, it has the numerator of the probability itself that we are looking at, the conditional one, is a probability. The denominator is a probability. So that always you see with the example that I'm going to give in the other videos, where we'll be just trying to emphasize on that.